Given that x equals 1 over sine theta, use the quotient rule to show that dx d theta is equal to minus cosec theta cot theta. Use the substitution x equals cosec theta to find this integral, giving our answer to 3 significant figures. Okay, here's the question in summary form then, part A. So x is equal, so dx d theta then is equal to v times du dx, 1 goes to 0, minus u, 1, times dv, cos theta, all over v squared, sine squared. This is 0, this product, so it's equal to minus 1 over sine theta then, times cosine theta over sine theta. So we just split that sine theta up into its two constituents. So this is minus cosec 1 over sine theta, and this is cot, which was what we wanted to show. So we've got that then. Use x equals cosec theta to find this integral here. Okay, so let's label it I, call it part B. So here I is equal to then, it's the integral between x equals cosec squared theta, so it's 1 over x squared, which is cosec squared theta, square root of cosec squared theta minus 1 here, dx. Now dx is equal to minus cosec theta cot theta d theta. Just squeeze that in there. Bit more room. Okay, and that's d theta. Right, so that's what we had. We'll worry about the bounds in a moment. I'm not going to worry about them just yet. Here I want to simplify this. Okay, cosec squared theta minus 1. Well, we know that sine squared plus cos squared equals 1. So cosec divide by sine, that'll be 1 plus cot squared equals cosec squared. So I divided the standard formula here, sine squared plus cos squared is 1, by sine squared. And we get this, so we now know what cosec squared minus 1 is cot squared. So this is equal to then the integral, and we'll worry about the bounds in just a minute. One of these cosecs will cancel, so it's just a cosec here. And then this one, the cot will be there. This cosec squared minus 1 is just cot squared, square rooted is cot. So that's a d theta. So that's everything taken care of there as well. So that's equal to, cosec is 1 over sine, so it's just minus sine theta d theta. Okay, and that equals cosine theta, doesn't it? The integral of minus sine. Now the bounds, first of all root 2, wasn't it? So we've got the substitution x equals cosec theta, x equals cosec theta. So we've got the bounds x equals root 2. So root 2 is equal to cosec theta, which is 1 over sine. Move the sine up. Sine theta is equal to 1 over root 2, or root 2 over 2. We can clearly see that theta is pi over 4. And 2 equals cosec theta. That tells, because that's the other bound, wasn't it, 2? That's sine is a half, if we invert the fractions both sides. And that tells us theta is equal to sine of 30. So it's pi over sine 30 is a half. So this is pi over 6. Okay. Root 2, yeah, okay, pi over 6. So our bounds are between pi over 6 and pi over 4. The pi over 4 is the bottom bound, and pi over 6 is the top bound. Okay, good. So that's equal to cos pi over 6 minus cosine pi over 4, which equals cos of 30 is root 3 over 2 minus root 2 over 2. Root 2 over 2, which is equal to a half. Root 3 minus root 2 if we want, which is equal to, now we need to work this out to 3 significant figures, because that's what it said in the question. 3 significant figures, so let's do that. So it's 0.5 times bracket root 3, square root 3, take away the square root of 2, close that bracket, equals decimal 0.159, isn't it, to 3 significant figures? 0.159, and that's the answer there.